Hello, I'm a student and I'm going to be taking Chemistry A. Start the timer. So, right off the bat, it looks like we have some sort of chart. I don't know exactly what it means, but let's keep going. There are blank carbon atoms in this parent chain. It is called blank. I don't know exactly what a carbon atom is. I only know what carbon is from the word carbon dioxide. Um, it looks like the number six uh, is how much like labels there are on this graph. So I'm gonna assume that it's probably six, and I don't know why six would refer to pentane, as pent refers to five and hex refers to six. So we'll go with six in hexane. Numbering of this molecule will begin at carbon blank. Again, I don't know where to start, but I'm gonna assume that it's probably Y, since, or, well, we don't have the option to start at Y. I'll go with A. Use this information along with the previous diagram to answer the following five questions. There are branches at carbons X, Y, and Z. So apparently these are branches, okay? The branches at carbon X are called, so at X, seems like they're referring to these branches, and there's this A logo or like sign here. So I'm going to assume it's one of these, since they're only one. Take a wild guess and go with this one. There is a type of branch that is common between carbon X and Z. What is it called? Okay, carbon X and Z. Nothing looks very familiar to me. I would think that X only has one option, so hmm, I guess if I logically determine it between these two, if the branch is at X and I think X it has one branch, it can't be these because there's no option here that matches that, so it has to be one of these. Well, carbon is able to make another bond. Maybe X, since it has this like empty branch here. What is the IUPAC name of this molecule? I'm not sure. The addition of a methyl group onto carbon blank would cause a change only to the name of the parent chain. I'm gonna go with A. Which of the following molecules is not an organic molecule? Well, just based on my knowledge, I know hydrogen and cyanide are both like natural substances or like molecules. So I'll have to go with one of these. I'll go with Go with tetrafluoromethane. Oh, methane is also like a naturally occurring thing, so I guess I'll go with tert butoside. How many valence electrons are present in butane? Butane is the thing that makes flames, right? And those are, I guess, 30. The element has the same number of electrons as butane has valence electron. Which of um, iron? Which of the following functional groups is most likely to emit a pleasant sweet smell? Sweet smell. Go with this one. Can your answer to the previous question participate in hydrogen bonding? Um, not sure. With my knowledge, I can't really answer that. Which molecule will have the highest boiling point? Well, these ones that start with H like remind me of H2O, which is water. I know water doesn't have that high of a boiling point, so I guess I'll go with one of these that start with a C. I'll go with this one. How many hydrogen atoms does an alkyne with N carbon atoms have? Seems like this is like a formula we should probably know. This one seems right. Use this information to answer the following 5 questions. Molecule name, ethanol, 1-heptene ethanolic acid, decane. I can see that they've listed the boiling points and also what the molecule is. However, I don't exactly know what an ethanol is or any of these things, so we'll try. Which molecules have London dispersion forces? I don't know what a London dispersion force is. Um, Seems like it's something with how the molecules separate. And I know when something is boiling, it the molecules move around faster. Maybe I'll go with ethanol, since it seems like it's the one outlier that's not very close to these other molecules. Assume each substance is a liquid at room temperature. Which one of these molecules can mix with water? It looks like ethanol has an H2O in here, so I'm just going to take a wild guess and say ethanol. Why can they mix with water? H2O. Despite that decane does not have a permanent dipole, its boiling point is much higher than ethanoic acid. Hmm. This point right here says all other molecules contain oxygen. Oxygen decreases the boiling point. I thought this was correct. However, 1-heptene does not contain any oxygen either. However, it has less, like around half as much um, of the boiling point as decane does. So I don't think this can be it. I would say decane contains most carbon atoms. Where would you expect methanol to take place in his list? Well, I don't know where methanol's boiling point is, so I'll take a wild guess and say above ethanol. Use this diagram to answer the following 4 questions. In addition, the addition of a methyl group to which carbon would not produce a molecule with a side chain. I do not know what a side chain is, so I guess let's go with all of them. The addition of methanol to which carbons would produce the same molecule. I feel like these two would, just based on nothing. I just recognize these. Well, I do recognize this symbol too in math. However, I don't see how they relate in chemistry. How many valence electrons are present in this molecule? Maybe 3, since there are 3 of them. What is the maximum number of propyl groups that can be added to carbon A? I'll say 3 again. The electrons in a benzene molecule are not fixed on one atom. The electrons in a benzene molecule are not fixed on one atom. They are well, if something's not fixed, I'm gonna assume something's separated. Just a wild guess. An acidic flavor compound has been discovered. It is naturally dissolved in an organic solvent. That is, it is nonpolar. It does not have any natural odor or color. In the lab, you are presented with 5 vials that may contain the flavor compound. How will you attempt to detect its presence? Well, an acidic flavor compound has been discovered. So acidic flavor compound has been discovered. It is naturally dissolved in an organic solvent. That is, it is nonpolar. It does not have any natural odor or color. In the lab, you are presented with 5 vials that may contain the flavor compound. How will you attempt to detect its presence? Add orange dye. Artificial orange dye will absorb into a acidic compound. Add water. Organic compound will readily dissolve in water. Touch it. Let's say add an orange dye. Sounds right. Let's check on our answers real quick. Yeah, I don't think checking is going to make any difference. Um, well, let's see what we got. 7 out of 25. Okay, let's 7 out of 25 isn't bad. Let's check our answers to see how well we actually did. Okay, it looks like the logic that we used here was pretty accurate. But let's see exactly why this was correct. Let's give this to ChatGPT. Use this as... Oh, sorry, let's set our timer. Use this as reference. Don't do anything yet. Let's give it the question. Again, it seems like whenever you give it a picture to help you study, which is pretty important in these topics like chemistry, biology, etc., where like a picture dictates your answer, and you so like this is yeah. Please explain why. I have no experience in chemistry at all. It seems like the model isn't able to remember the information it already knows by analyzing previously. So it has to keep analyzing every single time. Okay. It seems like it made this little chart here. That's pretty helpful. I don't exactly know what these C1 through C6 is, but I feel like someone that knows more about chemistry could probably use that. How chemists decide on a parent chain step by step. Every bend or end in the line drawing is a carbon atom. In a skeletal formula, the lines stand for bottoms and vertices, corners, or free ends represent carbon atoms unless another element is written. Look for the longest continuous route of carbons you can trace without lifting your pencil. In the sketch, you can just start at A, pass through the labeled centers X, Y, Z, then continue the zigzag to Y, and finally this symbol here. Check that no alternative route is longer. Dropping down from Y toward B would only give 2 more carbons before terminating. So any route through B tops out at 5 carbons. Or not B, but it looks like a B. Check that no alternate... the small 3-membered ring stuck at X is a side grid. None of its routes beat 6 either. I guess the number of atoms gives this name. I thought propane was what was the thing that you start like fires with like camping equipment. Butane. Well, one of these. I forget which one, but okay. Numbering of this molecule will begin at carbon. Well, this was explained earlier since we start at A and trace all the way to the other side. Use this information along with the previous diagram to answer the following 5 questions. Branch of carbon X. Let's see why this was wrong. Excuse me. This definitely takes a long time every single time I ask for a question. Three-sided triangle joined at X. Okay, I see. So this triangle at the top is actually also something that's connected. Oh, that makes sense. Let's see. Okay. So that straight line here is methyl, and this was like a cyclopropyl. Okay. Carbon between X and Z. Okay, I see this line right here was called a methyl. Which carbon is able to make another bond? Why is it Y? Now, oh, maybe it's this another line right here. But wouldn't that be the same thing with these two? Let's ask. Why only carbon Y can take another bond? X has 4 lines, 2 Y, do not know the group. Y has 3. 4 is an H with another association would give Y. Okay, let's see. The addition of a methyl group onto carbon blank would cause change only to the parent chain. It seems like if you give like even the slightest too much bit of like too much information to O3, it kind of hallucinates and takes way too long. Like a minute per response is kind of crazy when I'm trying to study. A chain end at the far left, B down the vertical sidearm, Y one of the two branches on carbon Z, the tip of the parent chain at the upper right. Terminal carbon of the main line. Only the parent chain root changes. No other names or numbers are attached. Okay, so it's kind of like it's kind of like the like an outlier, so that's why. Okay, this is kind of confusing. That hydrogen cyanide is not an organic molecule. Let's take out that correct answer thing. Maybe I'll make it generate faster. Okay, yeah, that made it much faster. A working level rule, as you meet in most introductory courses, is organic molecules contain at least one carbon. Carbon species without any CH bonds, carbon dioxide, O equals C equals O carbonates, CO3 2 minus carbides, and the fully halogenated fluorocarbons are classified as inorganic for teaching purposes, even though they still contain carbon. I guess this one was wrong. Are you sure it's not hydrogen cyanide? Is it inorganic technically though? Okay, so it's on a fence. I'm gonna assume that that means it's inorganic. Um, okay. How many valence electrons are in butane? Let's explain how this is calculated. That was pretty quick. Write the molecular formula. Butane has 4 carbon atoms and 10 hydrogen atoms. Well, I wouldn't be able to do that because I couldn't write it out. Recall the element's valence electron count. Carbon has 4 and hydrogen has 1. That's 26. Okay, that makes sense. So 4 for carbons, 1 for hydrogen. I just need to figure out how to know the molecular formula. Is there any way for me to know the molecular formula, or do just have to memorize them individually for all? Just for all. Okay. Seems like there's like a pattern. Okay, so you have a carbon to N, H to 2 times N plus 2. Okay. Which element has the same number of electrons as butane has valence electrons? We got that one correct. It's iron. Which of the following functional groups is most likely to emit a pleasant sweet smell? Let's explain this one. The sweet, fruity scent that candy, chewing gum, and ripe fruit share almost comes from esters RCOOR. Why esters smell sweet and fruity? Typical smell molecule example is banana, pineapple, wintergreen. Okay, so now we know that RCOO is the sweet one. Alcohol is ROH. Carboxylic acids are COOH. So that's like the opposite if there's the H after the COO. RX is odorless. Okay. There are no oxygen atoms. There are oxygen atoms, but they're not bonded to any hydrogen atoms. Yeah, that's true. Okay. Okay, so HCOH is the formic acid, strong hydrogen bonding. Yes, has OH. How can I tell which has a higher? Well, I have no. I can't understand this because I don't know anything about chemistry, so a simple answer like that doesn't make any sense to me. Okay, so hydrogen bonding has probably the most people. London dispersion, no significant polarity. Okay, so that's what London dispersion means. Okay, makes sense to me. How many hydrogen atoms does an alkyne with n carbon atoms have? Let's see. Oh, it was 2n because earlier we had like that formula. It was hydrogen to 2n, the carbon to n, yeah, so 2n. Okay. London dispersion forces, also called instantaneous dipole or van der Waals dispersion forces, arise from tiny moment-to-moment fluctuations in every electron cloud. Because every molecule and atom has electrons, every substance, whether it's highly polar, ethanoic acid, moderately polar, ethanol, or essentially nonpolar, one heptene experiences these forces. The stronger, the more familiar actions you may meet in class, hydrogen bonding, dipole, are additional to dispersion, not replacements for it. I don't understand anything you said. Remember, I have no knowledge on these topics whatsoever. Okay, every atom has electrons. Electrons are tiny, constantly moving charges. Moving charges make tiny moment-to-moment wiggles of charge. For an instant, one side of a molecule may be a little negative, the other a little positive. These fleeting charges attract neighboring molecules for a split second. With this snap together pull apart effect is what chemists call London dispersion forces, also called van der Waals dispersion. Because each molecule has electrons, each molecule shows dispersion forces. Bigger, heavier molecules feel them more strongly, but even the smallest ones have them. Okay, that makes sense to me. Um, Ethanol and ethanoic acid. Oh yeah, they both have hydrogen bonds. Okay, that makes sense. So it doesn't have to exactly have. So I was kind of right because I looked at the H2O right here. I thought that, oh, it has the same molecules as water. It can bond, but then the ethanoic acid also has hydrogen bonds that. would make it possible to mix with water. Despite that decane does not have a permanent dipole, its boiling point is much higher than ethanoic acid Y, or carbonic acid. Does that make sense? Where would you expect methanol to place in the list? This was a pure guess. Let's see why. Methanol will go above ethanol. It would be the very first lowest boiling entry on the list. Yeah, it's the smallest. Okay. Oh, so it's by the amount of carbons that they have. Well, not really. This one has 7 carbons, but then this one has 2. Has extra strong high. Okay, so it's the carbons, and then it doesn't have hydrogen bonds or not. This one has stronger hydrogen bonds. That's why. Let's give this diagram to ChatGPT. Let's try having it explain multiple questions at once. Nice. Didn't take that long. Perfectly symmetric, you can rotate the pentagon, doing superimposed any corner on the other. Total valence electron count. Looks like these are pretty good answers, but let's move on. IUPAC recipe for naming any straight chain alkyne. Okay, so this was what we were looking at earlier: methane, ethane, propane, butane, pentane, hexane, heptane, octane, noctane, dectane, decane, unicane, unidecane. So from pentane and up, it's pretty obvious what it's referring to. However, on butane, we just have to remember that methane is 1, ethane is 2, propane is 3, butane is 4. So, here's a quick reference snapshot of hallmark physical traits. Alkynes, straight from branched, colorless, oily liquids, gases, very waxy petroleum type. Low boiling point, rises smoothly. Insoluble in water, less dense than H2O. They float. Fruity flavors, slightly soluble. Lower when acids of the same size compared to ketones. Volatile, medium polarity liquids. Colorless liquids, waxy solids, very high for their size because molecules bear up. Small ones mix freely with water, large ones sparingly. Sharp, sour, or goaty, think vinegar or sweaty locker room. Okay. Aromatics, clear, highly mobile liquids or crystals, nonpolar but easily powders, moderate, usually higher than alkynes. Insoluble water, densities just under 1 G. They float. Okay. The 3 non-metallic, non-ionic intermolecular bonds you'll meet in freshman chemistry. The 3 okay. Hydrogen bond, a special dipole. H covalently attached to N, O, or F is highly. It is electrostatically attracted to a lone pair on a nearby N, O, or F. Okay, this is the one we were talking about, the hydrogen bond being the strongest permanent dipole and then London dispersion forces. London dispersion forces depend on how large and spread out the electron cloud of a molecule can become while it bumps against a neighbor. Two molecules that contain the same atoms in the same numbers can still differ in that contact area if they are different isomers or conformations. Isopentane, neopentane conformers of the same isomer, single bonds rotate. Yeah, I don't understand anything you said. Please remember, I have no chemistry knowledge. What are London dispersion forces and what's like this? Every molecule has electrons that wiggle around. Those wiggles make tiny movement to movement attractions that help the molecule stick together. That tiny stickiness is called LDF. Same atoms, different shape, different stickiness. Think of building with the same number of Lego blocks but arranging them in two different ways. Long bar, two bars side by side along their whole length, lots of contact, lots of stickiness. Compact ball, two balls only touch it at one small point, much less contact, weaker stickiness. In chemistry, those two shapes are called isomers. Same atoms, different layout. Both have the same formula, same number of blocks, but the long one has stronger London forces because its surface can press against a neighbor over a larger area. Okay, that makes sense. I think we learned about this earlier. C to the N, H to 2N plus 2. Carbon has 4 valence electrons and hydrogen has 1. Okay, yeah, that makes sense. What is a titration in plain words? Add one liquid to a burette, a chain to another solution that contains your unknown. The two solutions react exactly point for point until the unknown is used up. You watch for a clear endpoint, color change, pH jump, voltage jump, cloudiness, etc. because you know how much titrant you added and its concentration. You can do simple arithmetic to find out something hidden from the unknown. Okay. How that helps you identify an unknown molecule. Number of reactive spots, molar mass, titrant curve shape, stoichiometric ratio, putting it together, a step-by-step identification ready. Ways a more accurate mass of the unknown. Pick a right titrant, strong base for acids, a strong acid for bases, Ag for halides. KMNO4 for many reducers, EDTA for mental ions. Run the titration and note the exact volume of the endpoint. Do this, dude. Yeah, I can't understand much of any of this. Okay, for all the questions I asked you to explain, can you reiterate it in a whole study sheet for someone like me that needs to piece it together logically, since I have no previous chemistry knowledge. Okay, that was pretty quick. How to read line drawing. Every bend or free end equals a carbon atom. A carbon likes 4 bonds total. Hidden hydrogens fill the empty slots. Only atoms other than C or H are written in letters O, Cl, etc. Okay, we know about this already. Picking the parent chain as long as it continues trade route of carbon wins. Everything attached to it is not in that route side chain bread. All corners are equivalent, so adding one identical group to another corner gives the same amount of the different smells. That makes sense. Intermolecular forces building boiling point matter. Hydrogen bond needs OH, NH strongest. Hydrogen bond strongest. Permanent dipole-dipole is medium. London dispersion is weakest per contact but grows with size. Okay. We, even weak forces add up if the surface is big enough. Long floppy hydrocarbonations kind of wax melt boil higher than tiny alcohols. Lots of heavy atoms make clouds very polarizable, big dispersion. Lightning fast valence electron count for alkynes. It's the yeah, 4 from carbons, 2n plus 2 from hydrogens. Titrations as a detective tool, 1 minute version. Drip a known solution into your unknown until a clear endpoint, something happens. Volume times concentration of the titrant gives moles that reacted. For moles plus the mole mass you weighed, you get molar mass. 1 jump equals monoproduct, 2 jumps equals diproduct. Shape pKa values, narrow identity. Single titration can tell how heavy per mole is this acid. Does it have 1, 2, or 3 acidic hydrogens? What is its acidic strength? Often enough to name it. 9 pocket memory aids, 4 bonds for carbon. CH present equals organic. COOH gives very high BP and sour smell. Longer or less branched equals sticks better, higher BP. Valence electrons in alkyne equals 6n plus 2. Titration math, moles equals m times v, molar mass equals g divided by mole. Okay. What's this? I'm trying to remember these a little more. CRCOR is what's Estes? COO without the H is sweet. COOH is sour. When London dispersion beats H bonding, even weak forces adds up. Okay, we gotta remember that London dispersion is weakest, but can grow in size and get even stronger. Titration seems like it's just like in those shows when the chemist is pouring stuff into little containers and seeing what happens if he does that. And then based on like what you observe, uh, you use some simple arithmetic to figure out like the hidden stuff. C to the n and h to 2n plus 2. Alright, we got that. Alright, let's move on. We'll start with chemistry A. Looks like this UI component here is kind of messed up when you give it a file. Oh, that's pretty quick, actually. How many hydrogen atoms are in a straight line octane module? Ca backbone. Okay. So, so we know C to the N and H to the 2N plus 2. So 2 times 8 is 16, plus 2 is 18. So it should be 18. Valence electron total. The total number of valence electrons in propane is um, 3 times 4 is 12. 8 times 1, 12. So 20. Which functional group is most strongly associated with this pleasant fruity odor? I know this one. This one is D. Boiling point ranking. Which of these will boil highest at 1 atm? It looks like B has the most hydrogen bonds. Or maybe it's C. We'll go with C. London forces check all that apply. Which of the following always experience London experience forces? Pretty sure all of them do. Water solubility twin. Well, I remember that ethanol and ethanoic acid both have um, hydrogen bonds, so they should be able to dissolve in water. Boiling point logic. Why does decane boil far above ethanoic acid even though it lacks hydrogen bond donors? I think this was because it had a very large surface, so it had stronger dispersion forces. Isomer surface area. Which pentane isomer should boil lowest? Can't really answer this one, but I'm going to assume that they're all the same. Parent chain choice. In picking a parent chain, which candidate wins? Any 6-carbon route, longest continuous carbon route with fewest substituents. Oh, it's the longest carbon route, it should be. Ring substitution. Adding one methyl to any carbon in a perfect cyclohexane ring gives, I think, must be C, one molecule. 11 should be CN and then H2N plus 2, I think. Hydrogen bond test. Will the ester you named in question 3 accept, donate, or both accept and donate hydrogen bonds? In question 3, it will accept. Let's try this. Oh, great. did better than I expected. Let's see. So acyclic alkynes don't have the +2 at the end. Eight was asking it from 2 hydrogen bonds, highest boiling point. Propionic acid. Let's see. Okay, I guess that one was better. Branching versus surface area, more branching, smaller contact area, weaker London forces, lower boiling point. General formulas, alkynes, alkanes, alkenes, cyclones. Hydrogen bond needs H attached to N, O, or F. Esters can only accept H bonds. Acids and alcohols can donate and accept. Okay, let's just look through our answers again. We actually didn't too bad. I actually thought I would do worse. Let's see if we can get a couple more pointers. Small things. Okay, we gotta remember these. Symmetry saves time. Any perfect ring, triangle, square, pentagon, hexagon has equivalent corners. If you attach just one identical group, drawing it on any corner is the same molecule. Don't overcount. Okay, overall, I think we got the gist of everything. I mean, judging by our little practice questions here, slight issues on memorizing alkynes versus alkenes. Okay. All right, so now we'll do chemistry B. Let's just start a timer real quick. So it looks like we're hit with like another diagram. Um, some sort of molecule. So there are blank carbon atoms in the parent chain. It is called blank. So from studying, I remember that these should be the carbon atoms, and the name depends on how many carbon atoms there are. So there's one, two, three, four, five, 6, 7, 8, 9 carbon atoms. So it has to be one of these two. And because dec means 10, pretty sure this one is the name of the carbon atoms. And then numbering of the molecule will begin at carbon blank. So the numbering of the molecule should begin at the path which is longest. So like the path we can find that's the longest here without moving, or like without like if we tried to trace with our with like a pencil without lifting up the pencil, that would be like the longest line, and then the start of it would be the beginning molecule. So if we start it here, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So 7 is the most if we start from here. So 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. This one doesn't start as long. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So it's either this one at the top or this one. And I forget how to differentiate between the two, but I'll go with this one for now. Okay. Use this information along with the previous diagram to answer the following 5 questions. Consider possible branches at carbons X, Y, and Z. The branches at carbon Y is/are called. So at carbon Y, there's this X and this B here. I think one of them has to be 1, 2, 3, 1. Should be methyl and ethyl, if I remember correctly from studying. Which carbons can only make one more bond? Well, I think it must be Y. Because they each have 1, 2, 3, 1, 2, 1, 2, 3. I'm pretty sure they can make as most 4, so I think all of them can make only one more. 1, 2, 3. 1, 2, 1, 2, 3. Well, can only because X has 2 here, so 1, 2. Y and Z, I think. Which carbon is able to make 2 more bonds? Okay, yeah, I think we were right. So that would be X. What is the IUPAC name of this molecule? I think that was the one, like right here, right? It's called name. The addition of a methyl group onto carbon blank and blank would add an extra side chain. A and B, A and Y. I think it must be A and B. Which of the following molecules is not an organic molecule? Carbon dioxide has to be a organic molecule. Oh, see, I remember that an organic molecule has to have like a hydrogen bond, but I forgot what it should be bonded by. I'll go with methoxide because I feel like carbon dioxide can't be not organic, and these both have hydrogen atoms here. How many valence electrons are in methane? So methane, I'm pretty sure methane was after propane, so I think it was after. Methane means 4. So 4. How many hydrogen and carbon? Methane should be 4. The carbon is 4 carbons and 8 hydrogens. So, um, wait, no, methane is one. Methane should be one carbon. So N is one carbon, and two times N, so two times one hydrogen. So four plus four plus 4 plus 2 is 6, and I forget, is there a +2 or a -2? I think there's a +2, so it should be 8. Which element has the same number of electrons as methane has valence electrons? Pretty sure this one's carbon. Which of the following functional groups is most likely to taste sour? I remember that COO with an R at the end is sweet, so I'm pretty sure the one with the H at the end, the hydrogen at the end, is sour. Can you answer your answer to the previous question? Participate in hydrogen bonding. Why? Why not? Yes, it can. Um, there is a hydrogen at the end. Which molecule will have the lowest boiling point? So molecules that don't have like a hydrogen bond will usually have the lowest boiling point, but it seems like all of them have some sort of hydrogen bond. I would go with this one. How many hydrogen atoms does an alkyne with n carbon atoms have? Alkane with n carbon atoms. Pretty sure alkane doesn't have the +2, should it? So it should be 2n. Because +2 should be alkene. Which molecules can partake in dipole-dipole interactions? So dipole-dipole interactions is the one between a hydrogen bond and the lowest one. I forgot what it's called. Um, I'd probably put these three and not decanoic acid because it's just abnormally like high boiling point compared to the rest of them. And I'm pretty sure dipole was the middle, so it can't be the highest one, right? Assume each substance is a liquid at room temperature. Which of these molecules can mix with tetrafluoromethane? Probably put methanolic acid. Can they mix? Why can they mix with CF4? Why can they mix with CF4? Why can they mix with CF4? Just because they wait. I guess I will. I guess because they have a carbon. Despite the methanolic acid has fewer carbon atoms than methylcellulopentene, its boiling point is much higher. Why? Mm. Oh. Methanolic acid can participate in hydrogen bonding. I think that must be why. Because hydrogen, if it can participate in hydrogen bonding, its boiling point is much higher. Where would you expect propanol to place in this list? Propanol should be uh, 3 carbon atoms, I think. Either 3 or 4. So I would probably put it between methanoic acid and decanoic acid. Use this diagram to answer the 4 questions. In addition to the methyl group to which carbon would not produce, the addition of a methyl group to which carbon would not produce a molecule with a side chain. I think B, right? In addition to of a methyl to which carbons would produce the same molecule. For sure all of them would produce. How many valence electrons are present in this molecule? So there's 3 carbons, it looks like. So let's do 3 times 4 is 12 plus 6. 12 plus 6 is 18. Do I add the 2 or do I not? 3, 2, 18. 18. What is the maximum number of propyl groups that can be added to carbon A? Which is 1. The electrons in a benzene molecule are not fixed on one atom. They are, I mean, if something's not fixed, I'm going to assume something's separate, but I'm not sure how correct that is. A neutral dye has been discovered. It is polar. It does not have any natural odor or color without the presence of another chemical. In the lab, you are presented with 5 vials that may contain the compound. How will you attempt to detect its presence? You would use a titrate. Do we pick HCI or do we pick NaOH? I'm not sure which is the difference. Neutral dye has been discovered. It is polar. It does not have any natural odor or color without the presence of another chemical. In the lab, you are presented with 5 vials that may contain the compound. How will you attempt to detect its presence? What does polar mean? It does not have any natural odor or color, so it seems like HCI might be a better choice. Because I feel like since we need to make it react, then I guess doing something to like decrease the pH should be sufficient, but neutralizing the solution doesn't sound right. And these two right here, I'm pretty sure this isn't the correct way to like do uncover unknown substances in chemistry. I'm not sure if this one should be 18 or 20, because I forget if it gets added or not. I'm gonna go with 18 for now, because I don't think you need to add 2. How many valence? electrons are present in methane. We did that math already. Okay, I think we're okay for this test. We'll just take like a slow look around to see if we missed anything. There are blank carbon atoms in its parent chain. It is called blank. I mean, this one has to be nonane and has 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Has, and 9 cannot be decane because decane is 10, so we know it's that one. For this one, we know that the longest path is right here, but I'm not sure how to differentiate between the start and the end. So I guess we'll take a wild guess or like a 50-50 and pick this one rather than A. Branches that carbon Y is slash are called methyl, ethyl. Has to be methyl and ethyl. I can't see why it would have 3. Mm, which carbons can only make one more bond? Yeah, because these only have 3. These already have 3, Y and Z, and they can only have 4. I'm pretty sure. That makes sense. And then X is the only one with only 2 bonds, so they can have 2 more. Pretty sure this is the name of the molecule. I might be wrong. Carbon dioxide has to be organic. These both have the hydrogen bond, so I'm pretty sure it's an organic molecule. How many valence electrons are present in methane? We did the math for that one because methane means has like n equals 1 for methane. So C to the 1 and H to the 2 times 1. So H to the 2, C to the 1. Carbon is 4 valence electrons, H is 1. So then we do 4 plus we do 4 plus 2, which is 6, and we added 2 at the end. Which element has the same number of electrons as methane has valence electrons? Pretty sure it's carbon. This one has to be this one. I think RCOH should be sour. Alkane should be without the plus 2, so we do only just a 2. Hmm. We're not reducing molecule. The side chain will be. It's the only one that's different from these two. Same molecule. How many electrons? Okay, I think we're good. Oh, great. 10 out of 25. Much better than I assumed I was gonna get.